Okay, now we're going to look at horizontal stretching and shrinking. And horizontal is always the harder case because you have to undo what's been done to the x value. Just like when we had horizontal shift left and right, we shift left in the negative direction when we added a positive value, and we shifted right in the positive direction when we subtracted a value. And again, it's because I have to overcome those adding and subtracting. I need a bigger number in order to overcome those, or a smaller number to overcome those. The same thing works in the horizontal stretching and shrinking case, and I do believe this is the hardest transformation because it's counterintuitive the way you'd think. Okay? So, if we start with original graph, some y equals f of x, where you've got all the points in the graph for x and y. If you multiply inside the function, and it kind of carried over here, so I'm going to write it over here. So, if you multiplied by some constant inside, so you've got your x values, and all of your x values get multiplied by a number. And so that made all of your x values c times x bigger, and so to get back to whatever the original function values were, whatever those original y values were, you have to undo the multiplication. And so every point on the curve gets divided by that c value. Alright, so you have to undo it. So we divide by the c value. And really it comes down to whether the c value is positive, a big number, or a fraction. So if it's a big number, we divide by it. If it's a fraction, well, dividing by a fraction is the same as multiplying by the reciprocal. And so we are dividing, but we're dividing by the reciprocal, so it really comes out to I multiply by the value. Alright, but that's what we're doing. When we undo it, this is what we have to do. We have to divide by whatever that number is. Alright, so I'm going to do just a generic example here. So we're looking at this example of graph of f of x. So this is the original function. Alright, the 4 points that I've got graphed here, so this would be the first point, that is negative 2, 3, and then here would be negative 1, negative 3, and then that point would be 1, 3, and then the fourth point would be 2, negative 3. Alright, so those are my original points. I'm actually going to write them out here a little neater. Alright, so negative 2, 3 with the first point, negative 1, negative 3, 1, 3, and 2, negative 3. Alright, those are the 4 points that I've got graphed here of my original function, f of x. So this is the original. When we want to horizontally compress or shrink the graph by a factor of 1/2, all of the values of x get divided by 2. And how we do that, right, so this is the original. That's the original. In order to get a compression inside, we're going to multiply by 2. Right, f of x, instead of f of x, it's f of 2 times x. The function values are all the same. What we change are the x values. The x values get divided by whatever that number was out front. And so these were my x values. They all got divided by 2. So instead of getting to the function value 3 at 2, we get to the function value 3 at negative 1. 2 divided by negative 2 divided by 2. And same thing for the next one. Instead of getting to negative 3, the function value negative 3 at negative 1, we get there at negative 1/2, and the same for all of the rest of the points. All right, and so when we multiply by the x values, we divide to get to that number again. All right, and that's the hard part about horizontal moving. All right, so then what happens is that original graph got shrunk horizontally. Horizontally means left and right. It gets compressed horizontally, which looks to be a vertical stretch if you think about it that way, but it's a horizontal compression. So the new points, remember, were at negative 1, 3, negative 1/2, negative 3, positive 1/2, 3, and 1, negative 3, right? Those are the new points that are graphed here. If I go back and I put in the old points, remember the old points were at negative 2, 3, so this is what an old point was. 1, negative 3, so 1, negative 3, negative 1, negative 3, 1, positive 3, and then 2, negative 3. And so that's where we've been moved over. It shrunk. The old graph was out here further. You can see where my dotted lines are. That was where the dotted line, I guess I can draw the red. So the original function was here. Oops, that last one got a little funky. And so it got smushed to the blue one. All of my values for the x in the x direction, right? The x direction is a horizontal direction, got compressed in the x direction. Alright, so it smushed them in towards the y-axis. Vertical shrink is when it smushes it towards the x-axis. Alright, so again, it shrank it by a factor of 2. Alright, everything gets divided by 2. Alright, well, a stretch would be doing the exact opposite. Alright, so a horizontal stretch by a factor of 2, again, it has to do with the x values, all of the x values of the original function, that's not the x values, all the x values of the original function, get multiplied by 2. I have to undo the divide by 2. Right, and so we multiply inside the x by 1/2, and how that affects the graph is all of the x values have to overcome that 1/2 multiplication by getting multiplied by 2. Alright, and so that's what happens here. So again, all of my x values, you see them. I get to the same y value, but to get to the same y value, I have to multiply my x values by 2 because I have to undo this 1/2 x, right? My function is f of x to the 1/2 times x. All of my x values get multiplied by half to undo that, to get to the original, right? If I wanted to get back to the original f of x function, I would have to multiply by 2 to get back to the original. So that's what the idea here is. I have to get rid of whatever I've done to it. And so that's what literally happens. My original values were negative 2, 3, negative 1, 3, 1, negative 3. 2, negative 3. And then the new function, all of those y values got multiplied. Sorry, all of the x values got multiplied by 2. The y values stayed the same, so my x values were at negative 4 to get me to the 3, negative 2 to get me to the negative 3, positive 2, 3, and positive 4, negative 3. And so that's the new function. The old function was here, right? The old function was at negative 2, 3, negative 1, negative 3, 1, 3, and 2, negative 3. So this is where the old function was. And so you'll see, when we take a 1/2 inside, in order to get to the original function, I have to undo the 1/2 by multiplying by 2. And so all of the x values get multiplied 2. And so it stretches it in the horizontal direction because it's pulling it away from the y-axis. The x values are being stretched. Alright, so horizontal always has to do with the x values, and horizontal is always the case where it's the opposite, counterintuitive of what you think. The harder case. Alright, so stretch by whatever that factor is inside. Because if you use the same rule that we had, x divided by c, right? X divided by 1/2 is the exact same as 2x. Right, so again, it is the rule. It's just easier to think about it as multiplying by 2, but it is the rule where I take all of my values and divide by whatever that number is out front. But if that number is a fraction, dividing by a fraction is the same as multiplying by the reciprocal. Alright, so we'll practice a few more. Like I said, these are the tougher cases, so horizontal stretching and compressions. Alright, which again, I'm going to plot at least 3 key points just to help me out with these. So at least 3 key points, which I'm going to plot the original graph and then the compression or stretching graphs. So the original graph was that one we did before. It's a quadratic where it's been actually shifted down 4 units. So my original graph f of x, which I'm going to graph here. Right, and the 3 points that I'm going to plot are at my 0. So it goes down to the point 0, 4 is its vertex, and then the other two easy points to get are at 2, 0, and negative 2, 0. With a quadratic, 3 points are always what we want. Again, I said you have to plot. You can plot more than 2 points, but those are the 2 points that I'm going to plot. Right? So there is my original function. So there's f of x, the original, which is x squared minus 4. All right, now the new graph. All right, g of x. So g of x is when I took my original function f of x and multiplied the x values by 2. And so you take 2x squared minus 4, right? That's the process. So it's the 2x is completely being squared. So if I simplified that, it would be 4x squared minus 4. Right? You can do it either way, it's fine, doesn't matter. It's just easier to see that the compression here, it's a compression, right? It's shrinking it. So it's shrinking it by 2, right? It's compressing in the horizontal direction by a factor of 1/2 or 2. You can also say factor of 2. Divide everything by 2. All of the x values get divided by 2. The y values stay the same. Alright, and so my original points, think about this in terms of just the points. The original point was negative 2, 0, 2, 0, and 0, 4. So all of the x values get divided by 2. And so my new points are negative 2 divided by 2, which is going to come out negative 1. I'm just going to write negative 1 down. 0 stays 0. 2 divided by 2 is going to come out positive 1. And 0 divided by 0 is still 0. So 0, 4 is still where it hits the vertex. So it still starts here. But then it gets compressed. It moves, shifts in. And so the new points here was at negative 1, 0. And so it is compressed. Right, that would be my new point 1, 0. That's my new point negative 1, 0. And so my g of x, which is the red function, has been compressed horizontally. It's been pushed in the horizontal direction. It looks like a vertical stretch, but it's not a vertical stretch because that would move the vertex. But what it's done is it's pushed the x values in by 1/2. All of the x values on this graph get divided by 1/2, and that pushes it closer to the y-axis, right? And so it's the horizontal direction. It's been smooshed in, compressed in. Let's do another example of a stretching example. Alright, so same function, but this time we're going to multiply by 1/3. And so that means when I divide by 1/3, it's the same as multiplying by 3. So again, it's going to be stretched by a factor of 3. Let's start off with my original graph. So again, I'm going to graph the same function I had earlier. Give myself a little bigger space though, because I know it's going to be stretched when I go to graph my other function. So my 3 points, I'm going to use the same 3 points to start off with. So at 0, 4, 2, 0, negative 2, 0, that's the starting point. So there's my original f of x. So f of x. So again, my original points were negative 2, 0, 2, 0, and 0, 4. What's happening in this case when I go to graph h of x? Well, h of x took all of my x values and divided it by 3, or multiplied by 1/3, right? I have a 1/3 times x squared minus 4. And so it got stretched in the horizontal direction by a factor of 3. All of the x values get multiplied by 3. or divided by a third, but multiplying by 3 I think is the easier way to go. So my new x values, -2 becomes -6, 0 stays 0, that becomes 6, and 0 again is still 0. In that case, it's still at the 0, 4. And so it stretches it out. So now my new values, 1, 2, 3, 4, 5, 6, make sure I get enough, 1, 2, 3, 4, 5, 6. Let's do them red. Switch to red. So those are my new values at 6, 0 and -6, 0. Still hits the same vertex there. That didn't move. But these got stretched out, right? I got stretched out by a factor of 3, right? My x value, all of my x values in the blue function got multiplied by 3, and so that makes the parabola much fatter. It's basically pulling it out, pulling it away from the y-axis, and there's my h of x function, right? It's been stretched, and it's like I've taken both of the sides of my blue function and pulled them out left and right? Pulled them out horizontally by a factor of 3, right? And that's a horizontal stretch. And like I said, those are the hard ones. And the easiest way to remember about them, if I have a number up front, I've got to divide that number, if it's a big number. If it's a fraction, I would be dividing by the fraction, which is really multiplying by the reciprocal, and so I get to multiply and it makes it a stretch.